everybody, good morning. Ooh, noisy Max. All right, back to another adventure, back to another shift. Let's go. Coffee's ready, time for fun. Let's go wake this one up. Hey, beautiful day. Welcome back, everybody. Welcome back to another stick shift. And I'll tell you what, this weekend was quite unusual. Exciting and mundane at the same time, so to speak. I'm going to bring up a few interesting topics which you will see through the video. One regarding the Max, and a very interesting event that occurred with the 777. Well, interior is looking good. This thing is going out to Charlotte, I believe. Yeah, good airplane. There it is. Yep, it is going to Charlotte. Already checked up here, good to go. Now we're just going to wait. On to the next one. So before we move forward, I just want to let you know I'm going to post this a bit out of sequence, as in I'm going to edit this a bit because towards the end of this day, all I did is brake ride, and I usually leave that towards the end. So you're going to see a quick little short day, and then the next day is going to start. And if you want to just watch the brake riding session, that's going to be towards the end of the video. But in any case, let's get back to this day. And the last aircraft went out to Charlotte, and this Airbus is also going out to Charlotte. As I started doing my preliminary walk around and inspections, I found a problem. All right, office number 2. Well, almost office number 2. This was supposed to go out to Charlotte, but not anymore. I'm doing a walk around. Look what I found. One of the ATC antennas. Cracked. To be specific, this is the number 2 antenna of the ATC on the belly. You have to remember, there's multiple antennas. Matter of fact, there's a ton of antennas on the airplane, and here's a good representation. Check it out. You have everything from navigation and communication antennas everywhere. But right now, we're going to be focusing on the ATC number 2 on the belly. It is damaged. Superficially damaged, but still damaged. Now, why do I say superficial? Because there's portions of that antenna that actually function, and some of it is just protective aerodynamic covering. There are critical and non-critical areas. You have to understand that these little antennas are exposed to the elements as well as everything to the ground. That means a lightning strike could occur and damage that antenna. Continuous force of wind or the elements outside can cause erosion to the surface, especially to the leading edge of the antenna. And the most obvious, ground contact. Somebody inadvertently bumping into it, bumping their head, or a piece of equipment that comes colliding with it. A number of things can occur that can cause damage to these antennas. This is why we pay attention to these kind of details. In regards to the functionality of the ATC antenna, which is air traffic control antenna, it's allowing the operator of the corresponding equipment on the ground to locate and identify the aircraft in flight without having to communicate to the crew. What does that mean? The airplane is talking and somebody on the ground is listening. Now, I am simplifying this to the extreme. It's a lot more complicated. Take a look at this. This is all the systems the ATC transponders and the antennas talk to. Not only is it talking, it's also listening. And by the way, there's not only 2 antennas. Some aircraft have the option of having 4 antennas. 2 on the bottom, 2 on top. It is a vital system to navigation as well as communication. This is why as soon as I noticed that cracked antenna, guess what? That aircraft is now grounded. It's an easy fix, but it needs ground time. Yeah, it's definitely not going anywhere. They need that. Do not defer that. Now, there are variations and levels of deferral. Anything from minimum equipment list, MEL, configuration deviation list, CDL, or non-essential furnishings, NEF. This would fall under MEL. When I say levels of deferral allowment, well, this is particular to what station you're at. If this was some kind of a dire situation where it was on a station where we did not have maintenance or any possibility to rectify the situation or fix the antenna, then yes, there is a very specific deferral program where you can defer this for literally 24 hours, basically one flight. But we are a major station here, and we did have the components and the parts to change this out. I took the initiative. I said, look, this is the problem. We have the components, we have the parts. Unfortunately, the aircraft is going to take a massive delay for it, but the situation needs to be rectified. You cannot let the airplane fly like this in a Class A station. Even our maintenance control will just say, no, you can't defer that. And on top of that, remember, those things are sealed up. You need to allow time for that sealant to cure. Was trying to get the parts and trying to get the information to change out the antenna itself right there on the spot. But as it is on the line, we have no time because It's a live environment. Airplanes are coming in and they're going out. So what they did is they pulled the airplane off of the gate and put it to the hangar so the technicians at the hangar can replace the antenna. The job is really simple. It's simply one quick disconnect cannon plug and 4 screws. But the hurry up and wait part is allowing the sealant to actually dry. Now there are also stipulations for the sealant because the AMM, the Aircraft Maintenance Manual, even gives you provisions and allowances to allow the aircraft to fly without it being sealed, but for 10 days maximum. The whole point of this is that something that's critical, where it's able to get fixed, we will get it fixed. There are limitations, there are rules that we are following. We don't always go to the dire straits of bare minimum of saying, oh, just get the airplanes getting to go. If we have the capability to fix it, then guess what? We're going to fix it. And unfortunately, I had to ground that airplane. Even though there's redundancy involved, I'd rather have the aircraft being tip-top shape before it goes where it goes. I hope that made sense. Anyway, let's keep going. It's all right. They got to send it off to the hangar. They'll fix it up. They'll be back. It's supposed to look like that. And that's normal. That's just erosion. Oh well. Well, that's a special one. That's a P2F, passenger to freighter conversion. You don't see those often very much. I'm going to slow it down for you right here because I know somebody's going to think about it and going to ask the question, what is that smoke coming off of the landing gear? That's brake dust, guys. That's all it is. Brake dust. Those are carbon ceramic brakes, and during taxi operations, while getting to the runway, pilots are still using brakes. You get a little bit of wear and tear, and you get heat, and you get brake dust all over it. And that's what you're seeing, the wind blowing off the brake dust. Next, office. Our next aircraft is going to be a 737-8 MAX, and this is where one of the important topics I wanted to talk about, and it is a very sensitive topic. I'm going to be very careful of how I talk about this because it also involves another creator, a very famous pilot creator, which I'm sure everybody has seen his video, of him talking about this particular engine, the CFM Leap 1B. Now, mind you, I have incredible respect for that pilot. I have incredible respect for his knowledge of the aircraft. But I'll be honest with you, initially watching his video, I was very just taken back and I was saying to myself, wait a minute, I know this system. I've known about the system for a very long time. Seeing the video and looking at the title of the video itself, revealed, this system kills in 39 seconds. Nothing can be done. I'm sorry, but for me, that's clickbait. But the further I watched the video, I understood his demographic. I understood the reasoning behind it. I respect the reasoning behind it. He was trying to relay a very important safety message in regards to the aircraft. More importantly, to the engine of that aircraft and what it does. The system that I'm talking about is called the load reduction system or the load reduction device. If you haven't seen his video, I highly recommend you go check it out, but I'm going to sum it up from a maintenance perspective for you. I'm also going to put a very interesting twist on this. Bear with me. Okay, here we go. This is a nice cutaway of the CFM Leap 1B engine equipped on the 737 MAX, and let's take a look at the load reduction device, better known as the LRD. The LRD lives within the booster stage of the engine. This is right here between the fan and the compressor. To be more specific, it's right by the number 1 and number 2 bearing support assemblies. This is where the N1 shaft rides that spins the fan. So what is this actual protection device? Well, they are bolts. Actually, 20 fuse bolts that hold the number 1 bearing support on the number 2 bearing support. How does this system activate? Well, it activates when an engine senses heavy vibration within the case. Let's say if there was any kind of foreign object debris, FOD, that gets ingested, or a fan blade out, or a fan blade break off. And in this particular case that we're going to be talking about, there was a massive bird ingestion or a bird strike. As I mentioned earlier, the 20 fuse bolts that hold the number 1 bearing support onto the number 2 bearing support and the fuse pins that lock their load reduction device with the fan shaft bushing. In case of any kind of overload, such as a bird strike or ingestion, the fuse pins and bolts will shear. This prevents any kind of unbalanced loads being transmitted to the structure. Structure being the pylon, the wing, and the fuselage. These engines have vibration monitors and sensors, and in case the vibration gets excessive, trust me, you're going to feel it within the whole airplane. There's another important factor over here that you need to keep in mind. The important thing is oil. And look what's in between the number 1 and number 2 bearing, the A sump. This is where oil also circulates. These bearings and seals need oil. This is where we're going to get into the incident with a Southwest jet. This happened in 2023. The 737 MAX was climbing out through about 1,000 feet. The captain said bird, and then followed by an immediate thump. Number 1 engine had experienced a bird ingestion or a bird strike. Apparently this was a pretty big bird. Aircraft started to shake violently. They began to lose thrust. As with such an event, you began to have any kind of bells and the alarms start warning the pilots that something's wrong. Let's immediately go through their QRH, their quick reference handbook, and they begin to follow their procedures. The captain had called out for engine fire or engine severe damage or separation. The procedure is as follows. Conditions are if one or more of these occur: engine fire warning, airframe vibration, abnormal engine indication, engine separation, engine failure with smoke or fume in the flight deck or cabin. Step 1. Auto throttle. If engaged, disengage. Thrust lever. Affected engine, confirm, close. Engine start lever. Affected engine, confirm, shut off. Engine fire switch. Affected engine, confirm, pull. If the engine fire switch or engine overheat light is illuminated, engine switch, affected engine, rotate to the stop and hold for 1 second. There's another little step when this happens on the ground, but we're in flight, so we'll stick to that. If after 30 seconds the engine fire switch or engine overheat light stays illuminated, engine fire switch, affected engine, rotate to the other stop and hold for 1 second. If high engine vibration occurs and continues, it basically tells them to reduce speed. If it does not occur, continue with the checklist. Isolation valve, closed. Pack switch to off, affected side. There's more steps involved. This is a 20-step checklist. I want you to keep that in mind. This is happening very, very quickly in the sky. Remember this statement because this is where I'm going to put my little spin on this. And by the way, all of this data, if you want to go look it up yourself, is public knowledge. It's on the NTSB report, or what they like to call it, Aviation Investigation Preliminary Report. So now let's go back to the engine itself and let's take a look at the sump. Remember, I told you there's oil in there. The way the load reduction device is designed is when those things shear, the oil has to go somewhere. And guess where it's going to go? Straight into the compressor section. In my personal opinion, this is not a flawed design. It is doing exactly what it's supposed to be doing. Because at this point, the engine should have already been shut down. Keyword here, should have been shut down, but not in all cases this happens. Pilots are trying to save that engine. Also, that checklist takes pretty long to do. So as the pilots are going through the checklist, that engine is still somewhat spinning, and that oil is slowly going into the high pressure compressor. And guess what lives over there? Your bleed valves for your air conditioning and pressurization system, specifically your PRSOV valve, pressure regulating shutoff valve. Now you got all this oil going into the cabin, and that's exactly what happened with that incident. Since it was the number 1 engine that got hit by the bird, the number 1 pressure regulating valve sends the most of the air into the flight deck. Toxic fumes started to accumulate within the flight deck, and pilots had to don their masks to get oxygen. They proceeded with their checklist. As soon as they got to the step where they actually pulled that T-handle and stopped that PRSOV valve or shut it off, the fumes went away. You see, when you pull that little T-handle or the fire switch, there's actually 5 things that are occurring. Engine gets starved of fuel, or all fuel gets cut off, all hydraulics get cut off, all electricity gets cut off, most importantly, all air gets cut off, and number 5, you arm the fire bottle. So now we're back to square one of looking at what is the actual problem here. Is it a flawed design? Is it the procedural checklist that need to be modified? According to the FAA and according to CFM International, there is no problem. But they're still willing to work because now the NTSB is being involved. Their solution is working on some kind of a software update. Where such an event occurs, the PRSOV valve will automatically close. And I'm assuming it will close without having to pull the fire handle. My assumption would be redesigning it where the PRSOV valve is actually talking to the vibration monitor. If something that severe occurs and when the load reduction device is activated or the bolts shear, the PRSOV is automatically turned off. Or an update to the procedural manuals, the QRH, where pilots will simply reach up and close the isolation valve or that particular pack system. Quite an interesting situation and a very unique situation. This system has been around for quite a long time. It's on many different engines. It's not just on the CFM Leap 1B. The CFM Leap 1A has it as well, and pretty much any major high bypass turbofan. The design is slightly different on other engines, but the CFM Leap family is very particular on what those shear bolts. This is where I somewhat agree with the original creator, the pilot. And the other portion of it, I have my own opinion because death in 39 seconds is a bit far-fetched. You genuinely need to align the Swiss cheese model for all of that to happen. Not saying it can't happen, but a very low probability. Now, I know in aviation we try to eliminate the probability factor, and this is where I'm going to put my twist on it. It's us. It's human beings. Our reaction times. How fast do you react to a situation or an emergency like that? We can modify, we can fix, we can do all of these amazing things to these machines, but at the end of the day, you have human beings running the show, right? This is where automation is coming into play, taking control away from the human being. I'm talking about AI, artificial intelligence. Why do I bring this up? Because artificial intelligence or computerized systems can run through that checklist in a blink of an eye. You can have the very best pilot in the world, but that computer system will do it quicker, faster, and more efficiently. But that being said, you're taking the human element out of it. You're taking away the experience of the pilot. You're taking away the feeling and the instinct of a genuine good pilot. A good example would be the Sully landing on the Hudson. If Sully did not turn on that APU, trust me, it would have gone a much different way. Matter of fact, it's because of him they changed the QRH on the Airbus. All this being said, I know personally I have faith within the governing bodies as well as the manufacturers. I believe they will implement safety procedures and new things to improve these systems. But going to the extent of calling something like this MCAS 2.0 or saying that not if but when it's going to happen, I don't agree with that. This is such a rare case. And yes, I'm very well aware that it happened twice within a span of 9 months. Ironically enough, to another Southwest jet. But bird strikes are something that's very common and it happens all the time. Personally, I put my faith into the great, amazing pilots that perform their duties well. I also put my faith into the manufacturer that they designed the machine well. The 737 is a flying relic at this point to me. 1960s technology that has just been extended way beyond its time. I still have confidence within the aircraft. I still have confidence within the engineering and the pilots. I hope I did a decent job of explaining all of this to you, and whatever opinions that I express are my own opinions. Okay, enough about this, guys. Let's keep on moving. Next day is waiting for us. Good morning, everybody. Good morning. Let's go. Another beautiful day. Coffee's ready. Time for fun. Okay, first off of the day, let's see now. Do a quick little walk around, make sure everything's A-okay. The usual, guys. This one's a quick turn, so let's run through this. The wheel well of the 737 never fails to amaze me. Looks like a mess, but trust me, everything is organized. Looks like the inside of my brain. Well, this one just came in. It's gonna go right back out. I think going to Austin. Yeah, good airplane, good airplane. Oils are good, hydraulics are good. Oh, you know, somebody asked. Stig, sometimes on 737s we see these little things. What are they for? Well, I don't think it's anything official, but I know pilots use them to put their like little notes or whatever it is, stuff like that. But it's literally a paper clip that's been unfolded and put in there. I've never seen anything official on that though. I don't know, but they do it. Funny. All right, let's get out of here. Have I ever talked about this little unit? The yaw damper indicator. It's a rarity to see it on the modern 737s being built right now, but you still can catch it on some of the older models. The yaw damper system is an auto flight system which moves the rudder to decrease the airplane's yaw motion. This is caused by any kind of Dutch roll or turbulence. The system itself is powered by hydraulic system B. It's utilizing the main rudder PCU in the vertical stabilizer. There are two PCUs within the vertical stabilizer. Now, the yaw dampener indicator shows the rudder movement due to the SMYD #1 primary yaw dampening commands. SMYD referring to the stall management yaw dampening system or the computer. Now, the misconception here is it does not show the input from the rudder pedals themselves. It's simply looking and talking to the computer. Anyway, I thought it was a cool little unit. Nice little relic of the past right there. We gotta do it. Come on, too close for missiles. Switching to guns. Never gets old. We'll leave into the Mach warning speed. Test. I was walking by and look what's here. A PSA bird. Look at that. Ain't she pretty? I like this one a lot. This thing actually used to be a 319. Tail number 742 PS, I believe. Only airplane with a smile. With a nose job, apparently. Looks like they changed out the ray dome. Aw, it's all right. Still smiling. Ear to ear. Pretty airplane. List office. Let's begin. They have to reposition it. Came in international, but it's going to go out of a domestic gate, but it's still going out international. I don't know, but that's the way they do it. Anyway, going to do our quick little walk around, make sure everything's okay. The usual E-tops check going out. Heathrow, as always. This is one of our 200s. Lovely. When the aircraft came into International Gate, we did the preliminary walk around and I oiled the engines, but then it got repositioned and we continue with our ETOPS check. Once again, do another walk around, do the cargos, inspect the gears, make sure the brakes and tires are good, making sure the fluids are topped off, the usual. I've talked about this a million times, guys. The aircraft did come in with a few discrepancies. Majority of it was just interior, superficial stuff, trim here or a light bulb change. But there was one very particular write-up that was incredibly interesting. The aircraft went through some heavy turbulence. This was reported prior to the aircraft even landing because pilots were able to send the message out via ACARS. When the aircraft did get to the International Gate, we oiled the engines as quick as possible and then we ran upstairs because I needed a debrief from the pilot. When something important like this gets written up into the logbook, it's not only there as a record in the logbook, but it's a good practice to talk to the pilot to get the full explanation of what happened. And that's exactly what I did. So the write-up goes as such. I'm just going to summarize it for you. At flight level 340, the aircraft experienced some moderate to heavy turbulence. The moderate and heavy turbulence caused the aircraft to overspeed. There's multitudes of variations to overspeed. You can overspeed the engine or you can overspeed the airframe. In this particular scenario, it was the airframe that went into overspeed. Anyway, as a side note, I'm just going to keep going with the footage that you're seeing, but I'm going to be talking about this particular write-up and how we solved it. If you see something within the imagery here, feel free to just ask questions down in the comments. Okay, back to the write-up. So the aircraft experienced an overspeed due to the turbulence. In order to mitigate that, the pilot utilized his speed brakes to reduce his airspeed. Since the autopilot system is still engaged, as well as the auto throttle system is still engaged, the throttles went automatically to full power because when you're at that altitude, at that speed, and speed brakes get deployed, the airplane says, no, we need to go faster. Which, on the other hand, the pilot's saying, no, I want to slow down. Pilot then grabs the thrust quadrant or the throttles and pulls it back, also getting indication in their display systems. The indication is either MMO or VMO. This is in reference to the speed limits of the aircraft, VMO standing for velocity maximum operating, or MMO standing for Mach maximum operating. VMO is measured in knots. MMO is measured in Mach. Since the aircraft was in high altitude as it is, and they're going pretty fast at that point, it's going to measure with MMO. So they're going to get the MMO indication. Now here's the really, really interesting part and how smart these aircraft are. Before that aircraft even touched the ground, I already had the data and the specifics of what's happening to that airplane in live time. The aircraft's monitoring or health monitoring system is consistently sending the data down to us. Maintenance can access this. I can watch play by play, minute by minute, second by second of exactly what's happening to that aircraft when it's in flight. And just like that, with a few scrolling of my mouse and through my computer systems, I accessed the airspeed exceedance report. Only did it happen once, it actually happened 3 times. The maximum MMO for a 777-200 series is 0.87, but it also has a little bit of wiggle room of 0.05 MMO. So you add those up and the aircraft cannot exceed 0.92 MMO or Mach. When I looked at the live report and looked at all the 3 events that occurred of the overspeed, it did not exceed that limit, which is great news for me because if it did exceed that limit, then you have to go through a very massive and detailed inspection of basically the whole airplane. Everything from the top and bottom of the fuselage, wings, everything gets opened up. It's a whole big mess of an inspection. The other types of overspeed that I spoke of earlier, which is the engine overspeed, an engine can go beyond its own parameters. There's also limitations to that of how long was it going that fast. Same thing goes for other parameters of airframe overspeed, and that's regarding if the flaps or slats are down or if the landing gear is down during the overspeed. Once again, if that occurs, another massive inspection. I know somebody's going to ask, can we see the report? I apologize, that I cannot show you. That's very proprietary information, but I can relay the information to you like this. Overall, everything went okay. There was no issues with the aircraft and doesn't even call out for any kind of maintenance within the report itself, as if it did exceed that portion, it literally tells you, perform the check. Yes, I know this was pretty long conversation about this, but I thought it was interesting for you to know how airplanes record and how pilots experience these things and how we deal with it as maintenance. Airplane was good and got dispatched to London. I'm just going through the last portion of the parameters, making sure there's no faults, no issues, just the basic statistics of the aircraft and the parameters. Oh, and I forgot to mention, after we leave this aircraft, there was another 777-300 parked over to gate 41, and they had to do a air start. So if you want to listen to a GE90 starting up close, definitely listen to that. Well, this beauty is ready to go back to Heathrow. That's it. All we got to do is go back and do a little bit of paperwork. That's it. Fine aircraft. And don't forget, always check the fidget spinner. Make sure that's working. No-go item. Alrighty. That's it. Let's go. Here it is. If you enjoy a GE90 startup, definitely turn your volume up and turn your subwoofer up. Enjoy. Once the number one engine gets started up, the ground crew will disconnect the air source and the aircraft will be pushed back. Reasoning behind this is because the APU bleed function was inoperative. And yes, the aircraft is allowed to fly like this. It's an MEL, minimum equipment list. We've talked about it. But overall, it's a beautiful sound of a GE90 115B starting up. Everything rumbles. Your insides shake. It's just pure, unadulterated power that thing produces. Amazing. Anyway, back to my airplane, and here she goes. She's going off to London. There she goes, off to Heathrow. I was walking back towards the office, I caught this beauty rolling in. This is our Heritage livery. The only aircraft in our fleet, within all of our fleets, that is still painted or in this color scheme, the original one. The bare metal. Everybody loves this thing. This day is done, and now we're gonna rewind back in time. Remember, I told you in the beginning, I shot this thing out of sequence. Well, I'm posting it out of sequence. We're back to a day before, and the rest of this video is going to be brake riding. And if I remember correctly, I believe somebody did ask for a GPWS test on an Airbus, so that's gonna be in there too. Otherwise, enjoy the sights and sounds, and I'll leave the ATC chatter because you guys like it. All right, let's go. Man, this is an old airplane. Yeah, one of the old 319s. Anyway, let's take it for a ride. Brake riding. Should be fun. It still has the old CRT screens. They'll upgrade it eventually.
Glide slope. Pull up. Terrain, terrain. Pull up. Glide slope. Pull up. Terrain, terrain. Pull up. Sink rate. Pull up. Terrain. Pull up. Don't sink. Don't sink. Too low. Terrain. Too low, gear. Too low, flaps. Too low, terrain. Glide slope. Too low, terrain. Caution, terrain. Caution, terrain. Terrain, terrain. Pull up. Caution, obstacle. Caution, obstacle. Obstacle, obstacle. Pull up.
After the test is done, I'm simply confirming what I heard and saw, and the MCU gives me proper instructions, step by step. That's about it. There's your GPWS test, or ground proximity warning test.
East on Charlie, American 48 Bravo.
American 48 Bravo, proceed via Charlie to Charlie 17.
Charlie 17, American 48 Bravo.
Canada 7234 Heavy's ready for push. We got one started here.
Air Canada 7234 Heavy, push in ITC, your discretion to the top of the alley, please. Once you're at the top of the alley, your cross lead is approved. Runway 25 left.
Push the top of the alley, and once it's the top of the alley, second starter approved, cross lead, and 25 left Air Canada 7234.
Ground Scout 3786 for the Charlie 6 alley with Mike, rear for taxi.
Skywest 5786 LA ground, runway 25 right, taxi via Bravo.
25 right via Bravo Scout 3786.
Skywest 5786, monitor tower, good night.
Ground Scout 3786, a little mechanical problem, we can hold here somewhere.
Skywest 5786, roger, hold short of Charlie 3 and let me know.
Roger, hold short Charlie 3, Scout 3786.
Skywest 6229, clearing runway 25 right for gate 52 Golf.
Skywest 6229, LA ground, taxi via right turn Charlie to the box.
Charlie and box, Skywest 5229.
American 1676, LA ground, taxi via right turn.
Charlie ground American 1459 is vacating runway 25 right.
American 1459, LA ground, turn right on Charlie, taxi to the gate.
Turn right on Charlie, taxi to the gate, American 1459.
Skywest 5271, ATIS Mike is current, monitor tower 120.905.
Monitor tower Skywest 5271.
Skywest 5786, give way to an Embraer in front of you at Charlie 3, then make 2 left turns on a Charlie and hold short of Charlie 4.
I'm giving way to the Embraer on Charlie 3, left on Charlie.
All right, that's that. The usual. I always like the old steam gauges. The little red flags pop out when it gets unaligned. That's cool. That's it on this one. We got 2 more. Let's go. Not as spooky when there's still daylight, huh? One more time. Let's go.
Shall we go to ground north?
Yes, 0.65.
12165, Virgin 23.
And Los Angeles, ground New Zealand 3, heavy, kilo to hold short Charlie.
New Zealand 3, heavy ground at 25 right, taxi via Bravo.
Runway 25 right, taxi via Bravo, New Zealand 3.
And ground scale at 6315 at the box with Papa 25 right, available ready taxi.
So 6315, LA ground at 25 right, taxi via Charlie, Charlie 3 and Bravo.
Okay, 25 right via Charlie, Charlie 3 Bravo, scale at 6250.
LA ground is American Maintenance 1 at the top of Charlie 10 to Charlie 15 parking.
American Maintenance 1, LA ground, proceed Charlie to parking.
Proceed Charlie to parking, American Maintenance 1.
Sir, 6315, monitor tower 12095.
Tower scale 6350.
Sir, 6315, monitor tower 195. New Zealand 3 heavy, hold short of Charlie 6.
Hold short Charlie 6, New Zealand 3 heavy.
Ground American 2785, spot 1 on the Charlie 9, continuing. to push.
2785 on the ground, pushed out east on Charlie, expect runway 25 right.
Push tail east on Charlie, expecting 25 right, American 2785.
New Zealand 3 heavy, continue Bravo full length.
Continue Bravo full length, New Zealand 3 heavy.
Ground flight, please. So brakes.
Brakes are set. Thank you very much, man.
Brakes set. Copy that. Now have a good night.
There you go. Nice and easy. Everything else is already off. Headers are off. Emergency lights are off. I had the bleed off already. So. Okay, bus number 2 done. One more bus to go. Let's go. This is funny. Pilots thought this thing was going to stay at the gate, so they completely shut the whole thing down. It's all right. Got to power it back up. Poor thing. Bring you back to life, and then gonna put you back to sleep when we're done moving. Anyway, let's get this thing set up.
top of Charlie 9-2, Charlie 17 parking.
American Maintenance 1, ground proceed, Charlie to parking.
Okay, proceed Charlie to parking, American Maintenance 1.
Evening ground, Alaska 1280, Charlie 7 alley, request push on the Charlie.
Alaska 1280, LA ground, push back, tail to the west, runway 25 right.
I will push tail west, runway 25, Brian, Alaska 1280, thank you.
Ground Cafe 3280 on taxi. Cafe 3280, runway 25 left, taxi via Alpha, hold short of Foxtrot. 25 left, Alpha, hold short of Foxtrot, Cafe 3280.
Ground was 2 Echo, good evening and Juliet.
Fox 2 Echo, heavy array ground, good evening, taxi Charlie, Lima, short of Kilo 1 and call the ramp.
Charlie Kilo, Charlie Lima, acute, and round 8140.
Fox 2 Echo, heavy Charlie, Lima, hold short, Kilo 1.
Hold short Kilo 1 and the gate is 140.
Cafe 280, monitor tower on 2095. 1095, Cafe 3280. China 7420, heavy give way to traffic outbound, push back your discretion, runway 25 left.
Alpha outbound aircraft, push back for the runway 25 left, Saratoga 420 heavy.
Ground Delta 21 Alpha, checkpoint 2 to Wama.
Delta 21 Alpha, LA ground, proceed via Charlie, Yankee to Wama.
Charlie Yankee Wama, Delta 21 Alpha. Ground United 81, Charlie 6, go Charlie 3.
United 81 LA ground, proceed via Charlie to Charlie 3.
United 1277 crossing at Bravo 17, 75 Alpha.
United 1277 LA ground, taxi via Bravo Charlie 7.
Bravo Charlie 7, United 1277.
220 Heavy, start your push.
Echo, we are pushback on antenna for the 420.
Well, folks, this is the end of the shift. I hope you guys enjoyed the video. Thank you so much for watching. Thank you so much for being here. And as always, ask your questions down below. I'm always here for you, and I'm constantly trying to catch up with the comments.
Right, well, push your brakes.
Brakes are set. Thanks, man.
Brakes are copy. Thank you, man. Have a good night.
And that's it. This is the last one. Everything else is already off. Say goodnight. All right, that's it. Stig signing out. Later.